Okay, so this is the 26th lecture of engineering economy. Last time I just briefly introduced about the internal rate of return, which is about chapter 7. So I mentioned that the internal rate of return analysis is the most frequently used exact analysis technique in the industry. And the project's rate of return or internal rate of return is the interest rate that makes both present worth and the equivalent uniform annual worth equals 0. And basically the fundamental concept of the internal rate of return is that it's an interest rate at which the benefits are equivalent to the cost, or the present worth is 0. Okay, so today we are continuing to solve the end of chapter 7 problems. And the first problem that we are going to solve is, what about problem 7-8? Because the slides problem description is not ready at this moment, I'm going to just read the problem description from our text. So 7-8, a mining firm makes annual deposit of $250,000 into a reclamation fund for 20 years. If the firm must have $10 million when the mine is closed, what interest rate must the investment earn? So we've learned that the internal rate of return is the interest rate at which the benefits are equivalent to the cost. Okay? Benefits equivalent to the cost. Or present worth is 0, or future worth is 0. All those are equivalent term. So here we have $10 million equals $250,000. But you need to convert this to the equivalent future sum. So you need to multiply by F given A and I% over 20 years, right? So here, F given A, I% over 20 years is equal to 40. Okay? So we need to look for the table value of this. F given A, 20 periods. Okay. Actually, the compound interest table from Appendix C provides 40.996. %, 40.996. What about 6%? 36.786. So it looks like the table in Appendix C of our text does not provide interest rate that provides exact value of 40. It's very close to this value. But in order to get the exact value for internal rate of return, looks like we need to use linear interpolation technique. So we're going to use these two closest interest rate in order to minimize the error. Okay. So again, based on these values, we can sketch a very simple diagram. So the horizontal axis is the internal rate of return, 6%, 7%. Somewhere between there is a X% corresponds to 40. So we have 36.786 and 40 and 40.996. Okay, for this vector value. So if it's 7%, it provides 40.996. If it's 6%, provides 36.786. So you need to connect these 2 points. Then we have large triangle. So let's call this triangle B, and X% corresponds to the value of 40. So we have this small triangle. Let's call it triangle A. Okay. So what you need to do is compare these two triangles to get this value of X. Okay. So the height of triangle A is 40.996 minus 40 versus the base of triangle A is 7 minus X. Likewise, the height of triangle B is 40.996 minus 36.786 versus base of triangle B is 7 minus 6. Okay? And the inner product is equal to the outer product. So 7 minus X times 40.996 minus 36.786 equals 40.996 minus 40 times 7 minus 6. Okay. So here 7 minus x is equal to what is this value and these values as well. Okay, so this is 0.996 divided by 4.21. Okay, so what is the value of x? It is 6.763. So 6.763% is the internal rate of return. Which is the answer of problem 7-8. Okay. Okay. Then what about how about problem 7-9? You spent $1,000 and in return received two payments of $1,094.60, one at the end of 3 years and the other at the end of 6 years. Calculate the resulting rate of return. Okay. So we are solving problem 7-9. So let's draw the cash flow diagram. So you spent $1,000. And in return receives two payments of $1,094.60. One at the end of 3 years, 1, 2, 3. $1,096.60. And the other at the end of 6 years, 4, 5, and 6. There is another $1,096.60. Okay, and you want to know the internal rate of return for this cash flow. So in order to compute the rate of return, we may use present worth of benefit is equal to present worth of cost, right? So present worth of cost equals present worth of benefit. So $1,000 equals $1,096.60, but you need to convert this to the equivalent present sum. So you need to multiply by P given F I% over 3 periods plus another $1,096.60 again you need to multiply by p given f I% at this time over 6 periods, right? So what do you have here? P given f I% over 3 periods plus P given f I% over 6 periods is equal to 1000 divided by 1096.60. How much is this? Okay, so this value is 0.914. Okay, so let's use trial and error method. Okay, how about let's try 10%. For 10%, P given F over 3 periods is 0.7513. P given F I% over 3 periods is 0.7513. And P given F over 6 period is 0.5645. So this value, P given F I% over 3 periods plus P given F I% over 6 period, as how much is this? It's going to be approximately 1.316, something like that, right? And this value is a lot larger than this value, right? 0.914. So let's try about 30%. Okay, 30%. What is the value of P given F I over 3 and P given F I over 6? If it's 30%, it's going to be 0.4552. 0.4552. If it's over 6 period, it's 0.2072. 0.2072. Then if you combine these two vectors, how much is this? 0.6624, right? And which is smaller than this value. Okay, right here, 0.914. And this value is too low, right, compared to this. So let's try one more value. How about 20% or 25%? Let's try 20%. what is the value of P given F over 3 periods and P given F over 6 periods. Okay, there is 0.5787, 0.5787, and 0.3349, 3349. Then how about P given F over 3 periods and P given F over 6 periods? Okay, that's 0.9136, right? Which is very close to this value, 914. So maybe you can say that the rate of return is about 20% from here. Okay. Of course, if you want more accurate value of rate of return, then you can go with linear interpolation method. Okay. So this is the problem 7-9. Okay, what about we can solve about 7-10. So your cat just won the local violin lottery to the tune of 3,000 cans of 9 leaves cat food. A local grocer offers to take the 3,000 cans and in return supply 30 cans a month for the next 30 years. What rate of return in terms of nominal annual rate will you realize on this deal? Okay, so this is another very simple problem. So your cat just won 3,000 cans. Okay, this is problem 7-10. 3,000 equals, and the local grocer offers to take the 30,000 cans and in return supply 30 cans a month for the next 10 years. So it's going to be 30 times P given A, rate of return I, over the next 10 years. Okay, so supply 30 cans a month for the next 10 years. So what would be the interest period? How many months are there? The next 10 years. 120 months, right? So we're going to use 120 as the interest period. So P given A, I percent over 120 months would be 100, right? 3,000 divided by 30 becomes 100. So Now we need to look at the compound interest table. So P given A for 2% over the 120 period is 45, which is too small. What about 0.5%? P given A over 120 periods is 90.074, which is still smaller than 100. How about 0.25%? P given A over 120 periods is okay, a little bit over 100, which is 103.563. So obviously the appendix C of our text does not include interest rate that provides 100. So we're going to use linear interpolation technique to compute the value of the factor. Okay. So as usual, we need to find the two closest interest rates from the compound interest table to minimize the error. So it's 0.25% and 0.5%, okay, and X%. If it's 0.25%, P given A over 120 period would be 103.563. If it's 0.5%, P given A over 120 period is 90.074. 90.074. Okay. Okay. So again, we can draw simple diagram based on these values. Horizontal axis is the internal rate of return, so 0.25% and 0.5% and X%. Vertical axis is this vector value, which is 103.563 and 190.074 down here. Okay. So we have these two values, and you need to connect these two to make a big triangle, and then we got a small triangle as well. Okay, and let's call this small triangle triangle A, and this big one triangle B. Now our interpolation is rely on these two triangles, right? So height of A, which is 103.563 minus 100 versus base of A, that is x minus 0.25, equals the height of B, which is 103.563 minus 90.074 versus base of B, which is 0.5 minus 0.25. The inner product equals outer product. So x minus 0.25 times 103.563 minus 90.074 equals 103.563 minus 100. Well, there is 3.563, right? And 0.5 minus 0.25 is 0.25. And what is this value? This is equal to 13.489, right? Okay. So x equals 0.25 plus 3.563 times 0.25 divided by 13.489. So how much is this? Okay, this is 0.3166. Percent per month. So this is the monthly interest rate, right? And what is the question? It's been asking the rate of return in terms of nominal annual rate. So we need to get the nominal annual interest rate. How do you get it? This, what is 0.3166% multiplied by 12, because there are 12 months in a year. So how much is that? Okay, that is 3.7992%. That is the nominal annual interest rate. Okay, so that is for problem 7-10. Okay, and next problem that we are going to solve is what about how about 7-16? For the following diagram, we need to compute the rate of return. We are solving problem 7-16. Okay. So the given cash flow diagram is like this. And then the period 0, there is a cost of $42.55. And then the period 1, there is a benefit of $5. And then the period 2, there is a benefit of $10. And then $15, and then the period 3, and $20, then the period 4, and then $25, and then the period 5. Okay. So in order to compute a rate of return, we may use the present worth of benefit equal to present worth of cost. Okay. And here the cash flow, the positive cash flow can be broken into two components, right? One for the uniform annual series of $5. Another for arithmetic gradient series. Okay. 0, 1, 2, 3, 4, and 5. So at the end of period 2, there's 5, 10, 15, and 20. So arithmetic gradient of 5 here, and uniform annual series of 5 here. Okay. So here we are using present worth of cost. How much is that? That is $42.55 from here, right? And how do you get present worth of benefit? These are the benefit, right? So you need to convert this uniform annual series to the equivalent present sum of money. So how do you do that? 5 times P given A, I % over 5 periods, right? Also, you need to convert this arithmetic gradient series to the equivalent present sum of money. So plus 5 times P given G, I over 5 periods. Okay? So we need to solve this equation. So here, what you have is P given A, I over 5 periods, plus P given G I over 5 period is equal to 42.55 divided by 5. Okay, so that's going to be 8.51. Okay, so again, we may use the trial and error method to find out the interest rate that satisfies this equation. Okay, so let's try %. Then P given A over 5 period is 3.352. So 3.352. What about P given G over 5 period? Is 5.775. So how much is this? It's 9.127, which is larger than this value. So this time, this time let's use maybe 20%. Then P given A over 5 period is 2.991. And P given G is 4.906. So how much is this? It's 7.897, okay, which is smaller than this value. So you know that the interest rate that satisfies this equation should be somewhere between 15% and 20%. Okay. Okay, let me see. Okay, so here we are going to use linear interpolation. So we're going to record interest rate here, 20% and X% and 15%, okay? And then here 5 times P given A, I% over 5 periods plus 5 times P given A, I% over 5 period. I'm sorry, this is P given G, okay? That's going to be 42.55. And what about if it's 20%, then 5 times P given A, I over 5 plus 5 times P given G, I over 5. How much is this? Also, if it's 15%, how much is for 5 times P given A, I over 5 periods plus 5 times P given G, I over 5 periods. Okay, if it's 20%, it's going to be 39.49. And this is going to be 45.64. Okay, so we're going to record this value. For 20% is 39.49, 15% 45.64. Okay, so based on these table values, you can draw the diagram. I 15%, X and 20%. And then here 45.64, 42.55, 39.49. Okay. So we have this and this. And then here, this. Okay. Okay, marker. Okay, so here we have small triangle A and large triangle B. Okay, and our interpolation is rely on these two triangles, right? So again, the height of triangle A is 45.64 minus 42.55. Base of triangle A is x minus 15. Height of triangle B is 45.64 minus 39.49. Base of triangle B is 20 minus 15. Okay. Again, inner product is equal to outer product. So how much do you get? So in my calculation, this is going to be 17.38%. Okay. Wait a minute. Does the compound interest table provides 18% of interest rate, right? Okay. If you want to have more the accurate value, then I think you should go with you should go with 15% and 18% rather than 15% and 20%, right? Because we need to find the two closest interest rate to minimize the error. So I recommend you to go with 15% of interest rate and 18% of interest rate rather than 20% here. Okay, then you will have more accurate value than this. Sorry about that. Okay, then next problem that you are going to solve is what about problem 7-20 maybe? Okay. So let's solve 7-20. A bank proudly announces that it has changed its interest computation method to continuous compounding. Now $2,000 left in the bank for 9 years will double to $4,000. Then question A is asking that what nominal interest rate compounded continuously is the bank paying? And question B, what effective interest rate is it paying? Okay, so this problem dealing with continuous compounding. And again, the nominal interest rate and effective interest rate. So this is the problem 7-20. So in chapter 4, we have learned about compound amount for continuous compounding case, right? So, what is page number? What is that? Given, hold. Is that the chapter 4? I think it's chapter 4. Or is that chapter 3? Okay, let me look at chapter 3. Oh yeah, I'm sorry, it's chapter 3. So if you look at equation 3-12 in page number 94 of our chapter 3, it says for continuous compounding, F equals P times F given P R N becomes F equals P times E to the power R N. Is that right? So we are going to use this. $4,000 because the bank says 2,000 left in the bank for 9 years will double to 4,000. So 4,000 equals 2,000 and F given P R over N. And for the continuous compounding, this becomes e to the power Rn, right? And here, the n is 9 years. So 2,000 times e to the power r times 9. Is that right? So you need to solve this equation. So here, e to 9r equals 2, right? And take the natural log on both sides. 9r equals log of 2. So r is equal to log of 2 divided by 9. So how much is this? Okay, so it's going to be 0.0770 because here log of 2 is 0.693. Okay, so it's going to be 7.7%. Okay, that's the answer for part A. That is the nominal interest rate compounded continuously. Okay, that the bank paying. What about part B? Part B is asking the effective interest rate. So the effective interest rate be e to the r minus 1, right? So e to 0.0770 minus 1. How much is this? It's 0.08. So 8%. That is the effective interest rate. Okay. Okay, then I'm going to stop here for today. And next time, I will continue to solve end of chapter 7 problems. And next time, I promise, I will bring the slides for each problem descriptions. And okay, so this is all for today. Thank you. I will see you next time. Bye-bye.